In January 2024, an astronomer named Kevin Heinlein sat at his desk, staring at data from the most powerful telescope ever built. What he saw made him get up from his chair and walk down the hallway in silence. He needed to look at the faces of his colleagues. He needed to know if they were seeing what he was seeing. Because on his screen was a galaxy that shouldn't exist. It was too big, too bright, too old. The light from this object had traveled for 13.5 billion years to reach his telescope, meaning he was looking at something that existed when the universe was barely 290 million years old. That's like finding a 90-year-old man in the delivery room of a hospital, standing there moments after the first baby was born. When Heinlein confirmed what he was seeing, he laughed out loud. He later compared the discovery to excavating ancient Roman ruins and finding a smartphone buried in the dirt. This galaxy, now known as JD's GS Z14-0, is the most distant object ever observed by humanity. It sits at the very edge of what we can see. And what it reveals about the beginning of everything has left scientists scrambling to rewrite what they thought they knew. Tonight, we travel to the boundary of the observable universe itself. What astronomers found there is changing our understanding of how the cosmos was born. Before we can understand what astronomers found, we need to understand where they were looking. And this requires us to confront one of the strangest truths about the universe. It has an edge, not a wall, not a boundary you could touch, but a horizon, a limit to how far we can ever see. Light travels at 186,000 miles per second. It's the fastest thing in existence, the universe's ultimate speed limit. But even at that blistering pace, light takes time to cross the vast distances of space. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest star beyond our solar system, you see it as it was 4 years ago. The further you look into space, the further you look into the past. Now, the universe is approximately 13.8 billion years old, so you might assume that the farthest we could ever see is 13.8 billion light years in any direction. But here's where things get strange. Space itself is expanding. It has been expanding since the moment of the Big Bang, and it's still expanding now, at an accelerating rate. This means that while light from the most distant objects has been traveling toward us for nearly 14 billion years, those objects have been moving away from us the entire time. The result? The edge of the observable universe is not 13.8 billion light years away. It's 46.5 billion light years away. The entire observable cosmos stretches 93 billion light years across. Beyond that horizon, there is more universe, perhaps infinitely more. But the light from those regions has not had time to reach us since the Big Bang. They are forever beyond our sight, at least for now. What we can see, however, is spectacular, and at the very edge of visibility lies the oldest light in existence, and the first structures to ever form in the cosmos. To understand what astronomers found at the edge, we first have to understand what they've been looking at for decades, the cosmic microwave background. For the first 380,000 years after the Big Bang, the universe was utterly opaque. Space was filled with a blinding fog of superheated plasma, a churning ocean of protons, electrons, and photons so dense that light couldn't travel more than a fraction of an inch before being scattered. Imagine being inside a star. That was everywhere. But as the universe expanded, it cooled. And 380,000 years after the Big Bang, the temperature dropped to about 3,000 degrees Celsius, cool enough for electrons to finally bind with protons and form neutral hydrogen atoms. The fog lifted. The universe became transparent. And in that moment, light was set free. The photons that were released in that instant have been traveling ever since. Over 13.8 billion years, the expansion of space has stretched them, shifting their wavelength from visible light down into the microwave spectrum. They are now barely above absolute zero, just 2.7 degrees Kelvin. This ancient glow, called the cosmic microwave background, fills the entire sky. It's everywhere you look. It is, quite literally, the afterglow of creation. In 1964, two radio astronomers named Arno Penzias and Robert Wilson accidentally discovered this radiation while troubleshooting what they thought was interference in their antenna. They had no idea they were detecting the oldest light in existence. They would later win the Nobel Prize. Since then, satellites like COBE, WMAP, and the European Space Agency's Planck mission have mapped the cosmic microwave background in extraordinary detail. And in March 2025, the Atacama Cosmology Telescope released the clearest images yet of this primordial light. A snapshot of the universe when it was just 380,000 years old. But here's what's remarkable. This ancient light represents a wall. We cannot see beyond it. Before 380,000 years after the Big Bang, the universe was opaque. That means the cosmic microwave background is the absolute limit of what we can observe with electromagnetic radiation. But there's a gap, a dark age, between the moment the fog cleared and the moment the first stars began to shine. A period when the universe was transparent but unlit, cold, empty, waiting. What happened in that darkness? What ended it? That's what astronomers have been hunting for. And with the James Webb Space Telescope, they finally found it. After the fog lifted, the universe entered what cosmologists call the cosmic dark ages. There were no stars, no galaxies, no light sources of any kind, just vast clouds of hydrogen and helium drifting through an expanding void. But gravity was at work. Tiny fluctuations in the density of matter, imperceptible ripples left over from the Big Bang itself, began to grow. Slightly denser regions pulled in surrounding gas. Over tens of millions of years, these regions collapsed into enormous clouds, gathering mass, heating up under their own gravity. And then, roughly 100 to 200 million years after the Big Bang, something extraordinary happened. Deep within these primordial clouds, temperatures and pressures finally became intense enough to ignite nuclear fusion. Hydrogen atoms slammed together, fusing into helium, releasing light and heat. The first stars were born. These weren't stars like our sun. They were monsters, made entirely of hydrogen and helium, with not a single heavier element, because heavier elements didn't exist yet. These population 3 stars, as astronomers call them, could grow to 100, 200, even 1,000 times the mass of our sun. They burned with a ferocious intensity, blazing 100,000 times brighter than our star. And they lived fast and died young, burning through their fuel in just 2 to 3 million years before exploding as supernovae, scattering the first heavy elements into the cosmos. These explosions seeded space with carbon, oxygen, iron, the elements that would eventually form planets, oceans, and life itself. Every atom in your body, heavier than hydrogen, was forged in the heart of a dying star. For decades, no one had ever seen a population 3 star. They were too ancient, too far away, too faint. They existed only in theory and simulation, until November 2025. A team led by Ari Visbal at the University of Toledo announced they had found the first strong candidate for these primordial stars in a distant galaxy called LAP-1b. The light from this galaxy traveled 13 billion years to reach the James Webb Space Telescope, and inside it, astronomers detected stellar signatures that matched every theoretical prediction for population 3 stars. Massive, metal-free, clustered in small groups within dark matter halos. The gas surrounding these stars contained almost no heavy elements, consistent with a universe that had barely begun to cook its first ingredients. We may finally be looking at the very first generation of stars that ever shone. But the population 3 stars are not what made Kevin Heinlein get up from his chair. What shocked the astronomy community came from an even more distant find, an object that broke the rules entirely. JADES GS Z140 was first spotted in images taken in late 2023 as part of the jwst Advanced Deep Extragalactic Survey. It appeared as a small, reddish smudge, nothing particularly unusual at first glance, but something about it was strange. It was too bright, and it seemed uncomfortably close to another galaxy, as if they might be overlapping. In January 2024, the team pointed the Webb telescope spectrograph at the object for nearly 10 hours. Spectroscopy splits light into its component wavelengths, revealing how far the light has been stretched by the expansion of space, and therefore how far back in time we're looking. When the data came back, the room fell silent. The galaxy had a redshift of 14.32. That meant the light they were seeing had been traveling for 13.5 billion years. The galaxy existed when the universe was only 290 million years old, but that wasn't the impossible part. The galaxy was huge, over 1,600 light years across. It was blazingly bright, 5 times more luminous than the previous record holder, and its mass, hundreds of millions of times that of our sun. How can nature build something that massive, that bright, that large, in less than 300 million years? According to the models astronomers had developed over decades, it shouldn't be possible. Galaxies were supposed to grow slowly, assembling piece by piece over billions of years. The early universe should have been a messy, formless place, not a nursery for fully formed cosmic giants. And yet, there it was, staring back at us from the dawn of time. Nobody dreamed that there would be galaxies this bright at this high redshift, said astronomer George Rieker. The discovery didn't just break a record, it challenged fundamental assumptions about how the universe evolved. But there was more. Further analysis revealed something that should have been completely impossible. The galaxy showed clear signatures of oxygen. Oxygen is not a primordial element. It doesn't exist after the Big Bang. It can only be created inside stars. Massive stars that fuse lighter elements into heavier ones, then explode and scatter those elements into space. For oxygen to exist in jwst Z14-0, entire generations of stars must have already lived and died within this galaxy. Multiple generations, each one forming, burning, exploding and seeding the next, in under 290 million years. The presence of oxygen so early in the life of this galaxy is a surprise, the research team wrote. It suggests that multiple generations of very massive stars had already lived their lives before we observed the galaxy. Whatever happened in the early universe, it happened fast. Much faster than anyone thought possible. jwst Z14-0 is not alone. Since the James Webb Space Telescope began full science operations in 2022, it has found dozens of galaxies that shouldn't exist according to our standard models. Astronomers have started calling them universe breakers, objects that defy explanation. Some are too massive, some are too bright, some appear too mature, with features that should have taken billions of years to develop. One galaxy, jwst 7329, has a mass 4 times that of the Milky Way, and it existed just 800 million years after the Big Bang. The problem is this: according to the standard model of cosmology, dark matter collapsed into massive structures called halos during the first few 100 million years of the universe. Ordinary matter, hydrogen and helium, was then gravitationally pulled into these halos, eventually forming stars and galaxies. But the timeline was supposed to be slow. The halos were supposed to be small. The galaxies were supposed to be faint. What Webb is showing us is a universe that assembled itself far more efficiently than anyone predicted. Stars formed faster, galaxies grew larger, the cosmic engine ran hotter. Several explanations have been proposed. Some scientists suggest that star formation in the early universe was simply more efficient, that the conditions of the primordial cosmos allowed gas to collapse and ignite more rapidly than in later eras. Others propose that supermassive black holes formed much earlier than expected, providing gravitational anchors around which galaxies could assemble quickly. A more radical idea suggests that our understanding of dark matter itself may be incomplete, that the invisible scaffolding of the universe behaves differently than our models predict. And some have even speculated that these discoveries hint at something stranger still, that our universe may not be the only one, that we are observing echoes of conditions that point toward a deeper, stranger reality, a multiverse of possibilities we are only beginning to glimpse. The truth is, we don't know yet, and that's exactly what makes this moment so extraordinary. The universe is teaching us that we've barely begun to understand it. So what have astronomers actually found at the edge of the observable universe? They found the oldest light that will ever reach us, the cosmic microwave background, an afterglow from when the universe was just 380,000 years old. They found the dark ages that followed, a period of hundreds of millions of years when no stars shone, when the cosmos was cold and empty and waiting. They found the first stars, population 3 monsters, made of pure hydrogen and helium, burning bright and dying fast, seeding the universe with the heavy elements necessary for planets and life. They found impossible galaxies, structures that formed faster and grew larger than any model predicted, challenging our understanding of cosmic evolution. And they found questions, so many questions. But perhaps the most profound discovery is this: the edge of the observable universe is not empty. It's not a wasteland of faint, formless gas. It's vibrant, it's active, it's full of light and structure and creation. The universe was building things, beautiful, complex, luminous things, almost from the very beginning. And that changes everything. The observable universe stretches 93 billion light-years across. Within it, there are an estimated 2 trillion galaxies, containing more stars than there are grains of sand on every beach on Earth. And beyond our cosmic horizon, there is almost certainly more, perhaps infinitely more. Regions of space we will never see, because the light from them has not yet had time, and may never have time, to reach us. When Kevin Heinlein looked at that data in January 2024, he wasn't just seeing a distant galaxy. He was looking at a message from the beginning, a signal sent 13.5 billion years ago, carrying information about a universe just waking up. That light crossed unfathomable distances, traveling while generations of stars were born and died, while galaxies collided and merged, while on one small planet, orbiting one ordinary star, a species evolved that would eventually build a telescope to catch that ancient glow. The edge of the universe is not the end of a story. It's the beginning, and we are only just learning how to read it.